My name is Katja Bartsch, and I'm extremely excited to share this project with you. I'm a sports scientist and fascia researcher. I'm also trained in structural integration, and together with amazing colleagues like Bartsch, we would like to further research structural integration.
Hello, I'm Dr. Robert Schleib, Research Director of the European Roving Association, and I'm very pleased that we are now starting the first measurements of a study that we have been preparing for 3 years, and we are focusing on objective measurements following the successful example of the acupuncture research community.
We have recently published a study that was focusing on range of motion effects, so taking a biomechanical lens. And that's what we want to build on with this project also. Our study will have 2 parts. In one part of the study, we want to look at the effects of a single Rolfing-inspired technique on the low back area, and we want to analyze and look at the biomechanical properties before and after that technique with a variety of measurements. In the second part of the study, we want to look at the effects of a whole 10 series recipes. So taking data before and after the 10 series as they relate to posture and also the biomechanical properties of the tissues.
In the study, we will focus mostly, but not exclusively, on so-called objective biomechanical properties. One property is range of motion, in which we measure on several joints range of motion mobility. And we measure that with an electronic goniometer that is linked with a digital movement recognition. In addition, and there we are very proud, we have the Myoton Pro, and that does a tiny indentation at the tissue. Let me see if I can quickly do it. You press it on the tissue, and now you see it becoming green. Yeah, so it made a very short indentation on the tissue. And then we have a measurement of the stiffness of the tissue in Newton per meter, but also of the elastic recoil. That tool has been used at the ISS, at the International Space Station, with the astronauts to measure their stiffness properties as they are in weightlessness. And we want to use the same highly precise tool to measure any kind of tonus changes in myofascial tissues associated with Rolfing application. In addition, we have the Indento Pro that basically uses the same measurement principle. You cause an indentation, a vertical deformation of the tissue by pressure, and you measure the resistance force. And that tool was developed over 10 years by our colleagues at the Technical University of Chemnitz. The advantage of this tool is you get the tissue response at different depths, up to 10 millimeter steps, and that is an additional quality that we eagerly look forward to include in that examination.
We are really excited to share this project with you, the structural integration community, and we do hope that you support our endeavors as well. Thank you.